The next step in PERT is to assign time estimates for each activity. Usually, managers are unsure how long each activity will take. To overcome this, instead of giving one time estimate, PERT gives three time estimates: optimistic time A, most probable time M, and pessimistic time B. In this table, we see that for activity A, the optimistic time is 1 week, the most probable time is 2 weeks, and the pessimistic time is 3 weeks. For activity B, the optimistic time is 2 weeks, the most probable time is 3 weeks, and the pessimistic time is 4 weeks, and so on. What do the three time estimates in PERT refer to? The optimistic time A refers to the best time. The most probable time M refers to the time under normal conditions. The pessimistic time B refers to the worst time. For example, consider driving from Bandar Melaka to KLCC. If there are no traffic jams, for example during the weekend, the drive takes about 2 hours 30 minutes. So the optimistic time A is 2.5 hours. During a working day, before peak hours, the drive takes about 3 hours. So the most probable time M is 3 hours. But if a person is caught in the traffic jam, the drive can take up to 4 hours. So the pessimistic time B is 4 hours. From the three time estimates, we can calculate the expected time. This is given by the formula expected time equals to A plus 4M plus B divided by 6. Back to the example about General Foundry. We can calculate the expected time using the formula A plus 4M plus B divided by 6 for each activity. For activity A, expected time is 1 plus 4 times 2 plus 3 divided by 6. 4 times 2, 8 plus 1, 9 plus 3, 12 over 6 is 2. For activity B, expected time is 2 plus 4 times 3 plus 4 over 6. 4 times 3, 12 plus 2, 14 plus 4, 18 over 6 is 3. We calculate the expected time for the other activities. We can also calculate the variance for each activity. The variance is given by the formula B minus A over 6 squared. For activity A, the variance is 3 minus 1 over 6 squared. 3 minus 1 is 2, 2 squared is 4, 6 squared is 36. For B, it is 4 minus 2 over 6 squared. 4 minus 2, 2, 2 square is 4, 6 square is 36. We calculate the variance for the other activities. The reason the variance are given over 36 is later on we want to add the variance. It is easier to add if the denominator is all 36. Previously, we have drawn this project network. In this network, these are called the nodes. The nodes are drawn as circles. Another way of drawing the node is as follows. Activity is the name of the activity, like A, B, C, and so on. Expected time is the expected time we calculated earlier for each activity. ES stands for earliest start. EF stands for earliest finish. LS stands for latest start. LF stands for latest finish. Now we draw the network diagram again using the square nodes. Previously, we have calculated the expected time for each activity. Now we enter this expected time into the project network. For example, expected time for activity A is 2. So we enter 2 here. For B it is 3. We now fill in the values for earliest start, earliest finish, latest start, latest finish for all activities. We start from 0. From start, we go to A and B. So we put in zeros for A and B. The time for activity A is 2 weeks. So we end activity A 2 weeks after 0. That is 0 plus 2 is 2. Similarly, we end B at 0 plus 3 is 3. After finishing A, we immediately start C. We finish A at 2, so we start C at 2. We end C at 2 plus 2 is 4. We end B at 3, so we start D at 3. We end D at 3 plus 4, it's 7. Now we continue. For activity G, we can either start at 8 or 7. So which value do we start G? To answer this question, I discuss another example. Suppose the Silat Society from UiTM Segamat and UiTM Jeka wants to attend a competition at Shah Alam. The plan is as follows. The team from Segamat and Jengke will meet at Melaka. There they will take a bus to go to Shah Alam. Both teams from Segamat and Jengke leave at the same time at 10 AM. Because Segamat is nearer to Melaka, the team from Segamat arrives Melaka earlier at 1 PM. The team from Jengke arrives Melaka later at 3 PM. The question is, what is the earliest time the bus can leave to Shah Alam? Even though the team from Segamat arrives early at 1 PM, the team has to wait for the team from Jengke to arrive at 3 PM. So the earliest time the bus can leave for Shah Alam is 3 PM. So therefore, between 1 PM and 3 PM, the earliest start is the bigger value, which is 3 PM. We obtain the first rule for entering the times, which is earliest start is the largest earliest finish of immediate predecessors. According to this rule, between 8 and 7, we choose 8 because it is the larger value out of these two values. For activity H, earliest start can either be 7 or 13. According to this rule below, we choose 13. This part of the operation, where we find the earliest start and earliest finish of all activities, is called forward pass. Now we find the values for the latest start, latest finish for all the activities. For activity H, the earliest finish is 15. So therefore, we go back from 15. So we enter 15 as the latest finish for H. To find the latest start, we minus the time 2. That is 15 minus 2 is 13. Then we continue. 13 minus 5 is 8. 8 minus 4 is 4. 13 minus 3 is 10. For activity C, the latest finish can either be 10 or 4. To know which value we should choose, I discuss another example. Suppose you have to finish a project. You have to submit this project next week to 2 lecturers. For the first lecturer, the deadline is on Friday. For the second lecturer, the deadline is on Wednesday. The question is, when is the latest you should finish this project? If you finish this project on Friday, the first lecturer will accept your project, but not the second lecturer, because her deadline is on Wednesday, so you cannot finish by Friday. So the latest you should finish is on Wednesday. so that the second lecturer can receive your project. The first lecturer can receive your project, but you submit it early, which is okay. So between Friday and Wednesday, you choose Wednesday, which is the earlier value. Now we have another rule, which is latest finish is the smallest latest start of the following activities. When we wanted to fill in the latest finish for C, the latest start for the following activities are 10 and 4. According to this rule, we choose the smaller value, which is 4. So we enter here 4. 4 minus 2 it's 2. 2 minus 2 it's 0. Here we enter 8 minus 4 it's 4. 4 minus 3 it's 1. This process of finding the latest start and latest finish is called backward pass. After completing the project network, we want to find which activities are the critical activities. To do this, we first discuss about slack. Slack is the amount of time an activity can be delayed without delaying the whole project. Slack is given by either latest start minus earliest start or latest finish minus earliest finish. Remember that if we delay a critical activity, the whole project will be delayed. Therefore, if we want to complete the project on time, we cannot delay a critical activity. Thus, for a critical activity, there is no slack, or slack equals to 0. Since slack is equals to latest start minus earliest start, therefore we set latest start minus earliest start is 0, or earliest start equals to latest start, or latest finish minus earliest finish is 0, or earliest finish equals to latest finish. An activity is a critical activity if the earliest start is equals to latest start and earliest finish is equals to latest finish. So we see that activity A is a critical activity because earliest start and latest start are both 0 and earliest finish and latest finish are both 2. Another critical activity is C and also E, G and H. We give the answer as the critical path. So the critical path is equals to A, C, E, G, H, and also the project completion time is equals to this value here, which is 15 weeks. We can also calculate the project variance. Project variance is the sum of the variance of the critical activities. Note that we don't use all the activities, only the critical activities. Previously, we have calculated the variance for each activity. We have also found the critical path is A, C, E, G, H. Project variance is the sum of the variance of the critical activities, which are A, C, E, G, and H. So project variance equals to 4 over 36 plus 4 over 36 plus 36 over 36 plus 64 over 36 plus 4 over 36 equals to 112 over 36 or 3.11.